Good day, everyone. Welcome to our EnRoute webinar of today. Today we'll be covering toolpathing. Just wondering if everybody is able to see my screen all right. If so, could you please note that in the chat? Right, okay. Let me just try to fix that. I'll turn off the sharing for a second and reshare it. All right, perfect. Yeah, I saw it flashing in my preview as well. All right, so today I thought we'd talk about the general toolpathing in EnRoute. Mostly we'll cover the 2D ones like the routing offset, the hatch fill, the island fill, the engraving strategy, as well as some of the drilling strategies. If you have any other questions or you'd like to review another toolpathing strategy, just let me know in the chat box and we can cover that one as well. So let's get started. Let me just see what size we have here. Let's do maybe 1 meter by 1 meter. Maybe do a thickness of 10. All right, so I suggest we start out with the routing offset, which is going to be one of the more simple ones. So we'll cover all of the options of the strategies. You'll notice that they're similar between a lot of them. So let me just grab a letter T, for example, that in here. And then so the routing offset strategy we can find here, or we can go into the toolpath menu and we can pick a routing offset in here. Whenever you put a toolpath to a text, it'll ask you, or EnRoute will ask you to convert it to curves first. So we'll do that in this case. Let me just remove the tools that we have here. So here you see all of your available tools that you can apply to this strategy. You can go to all tools, but it'll be, for this strategy, easier, or most of the times you will be working with the end mills that we have here. Perhaps working with EnRoute, you've noticed you have to set a depth for you to be able to accept the toolpath. For the routing offset here, you have some of the parameters here, so you can go for an external one or an internal cut. Do the welding offset, so if you have overlapping toolpaths, that it would weld them together. Sharp corners is an option you can check here as well, which means I will just show you. If you uncheck it, you'll see that it makes a round corner here. It has no effect on the shape of the actual corner. It'll be a squared corner. But for the smoothness of the movement of the machine, rounded corners are good to use. You can set sharp corners as well. As you'll notice, then it'll the movement of the machine is going to be sharp here as well. That makes little difference for the round tools like end mills or ball nose tools. But if you, for example, take a conic tool or an engrave tool, set that to a certain depth, let's say 10. I'm just going to copy this over. And for this toolpath, we will set this, we'll turn this off. And then if we just draw a contour around it, hopefully see it like this. So you'll use material color. seem to be getting an error. Let me just restart EnRoute for a sec, because I've been messing around with it for a while. So put that here. So grab that T again. And then let's go into the routing offset again. So we'll take our conic tool here, let's put it to 10, choose sharp corners for this one and for this one. So you can also right click and the object and use to create toolpaths, routing offset again. And for this one, we'll uncheck sharp corners. And then let me just scale it down like this. I'll put it to 500 by 500. Right. As you can also see, if you rescale your contours, the toolpaths will automatically be recalculated, and the offset for them as well. So the offset to the contour will typically be half the diameter of your tool, so that you're actually cutting the shape you've designed in your contour. So as you can see, if you're using a bevel tool, checking or unchecking the sharp corners will have a tremendous effect on the, as you can see, the top corner here is always going to be square on both sides. But if you're going to use the conic tool, the tip will cut with square corners in a square, and with the other ones, it'll follow that rounded shape that's made by default. So that is something you have to keep in mind. All right, so stepping back into the options, let's just uncheck this one here. You have the possibility to create inlays. Let me just show you what that is. So if you want to mill out a pocket and then put a letter in there, let's say, just going to delete this toolpath, resize this one a bit. So let's say we want to mill out a pocket here. For this one, we would probably take a hatch fill or an island fill. We'll take an end mill. Let's do the 4 mil down shear. Let's go to a pocket depth of 8. Let's do 4. Our fill, since it's an end mill, depending on the material, you can lower this by a lot. In this case, I'll just put it 20% overlap. These ones we'll cover in a bit. And here we'll pick inlay, and we'll choose our inlay gap, which is going to be the complete gap between the pocket and the inlay. And then here we'll confirm this. And for the letter we're going to route out, we'll cut to a depth of 10, but we'll also use that for that same tool. So you always have to use the same tool to cut the pocket as well as the inlaid piece. Here we'll say inlay and put that gap of 1 millimeter. So if we then visualize the toolpath, then this letter will be able to, let's just use Control-5 to center it to the plate. We'll be able to inlay these ones perfectly into each other. So if you check that inlay option, what that'll do, it'll tell EnRoute that it has to mind tool diameter for both the inside and the outside corners for both the male and the female cut, so that they can be perfectly laid into each other. The thing here is you won't be able, so EnRoute cannot or does not calculate the differences in between tools. So you cannot use an 8mm bit for one cut and a 4mm bit for the other one. Something to keep in mind. And previewing the toolpaths like this, you can simply do by hitting F9. Going back into our options, we'll just uncheck the inlay again. In here, we'll also be able to add bridges. So there's several types of bridges. To get a preview of these, you could consult the manual. Parameters for the bridge consists of bridge length as well as bridge height. And you can set a number of bridges or set it by distance, or choose to add bridges manually. Alternatively, if you have not added bridges in the toolpath, at a later point, you can go back into the toolpath menu here and choose Edit Bridges. You can right-click Insert Bridges and then just click on certain spots to add the bridge in there. So going further, hitting the three dots here, you can hit the properties of your toolpath of the specific tool. So here you'll be able to define the depth. The final depth will be 10. You also have the possibility to offset the surface. Let's say you've already made a toolpath that is being routed before this one, and it has already cut away like 4mm. Then to reach the depth of the plate, you would have to only route 6mm deep. So the final depth is always in relation to the surface. So if you want to tell EnRoute you don't have to route that first 4mm anymore, you can just set the surface to 4 and then the final depth to 6, coming to a total of 10 to route through it. The number of passes will always be defined based on the maximum per pass that your tool allows, but you are free to add in additional passes or change the maximum per pass here to, let's say, 3, and then EnRoute will automatically calculate how many passes it'll do and how much it will actually route per pass. So depending on the material, you can play around with these here. Set that back to 12. Here you have the possibility to add a final pass. So going to a depth of 10, we could do a final pass of 0.5 millimeter. Some people refer to this one as an onion skin. So you could route out all your objects and then sort in the ordering process. You can order them by passes so that it will route out the final pass last for each object. This way, the vacuum will hold the material in place until you route out, or will keep the optimal amount of vacuum on the piece until you route out the final passes. The width of cut is typically used to offset additional tools that you add in here. So if you say, let's say we use a 4mm tool and we want a width of cut of 8, and it's going to calculate multiple passes to do that width of cut. So here we've defined that 8mm has to be routed, so we add additional circles around here. but this will become more clear if you actually add in an additional tool. Your feed rates you can find in the cut definition as well. So you can set your feed rates here per second, per minute. Choose inches per second or minute. These can be set default in the preferences, but you can choose them for an individual cut here as well, and then EnRoute will automatically calculate them towards the ones that are set in your driver to create the right output file. You can set up a different speed for your final pass. You have your plunge rate here as well. So typically I would set the plunge rate to half that of the feed rate, but depending on your material, that will vary as well. Dwelling is more of a legacy option where you would tell the spindle to dwell above the material before plunging in. But that is from back in the day where these spindles would require some time to get up to speed. So typically that isn't used anymore. And then your spindle speed in rotations per minute. Let me just check. Hi, Royce. I can get in touch with you at a later point, and maybe we can cover that through a TeamViewer session, if that's okay for you. So here we have the direction we can choose here as well. So we have conventional or climb. Conventional will cut or will put the toolpath counterclockwise, while climb will cut it clockwise, and that will define as to whether you will be chipping material away from your object, or that you will be chipping into the piece. And lastly, here we have our entry and exit parameters. So here you'll be able to define how the tool is going to approach the final contour. So you can arc into it, which will let you set a radius, an angle. You can set a lift here as well. Typically, the ones I use would be either the line. No, mainly I use the line. So I set up the length of it. So let's do 30 mil and an angle towards the piece. And for the exit, I would do the same. So 30, 20. And let's change this width back to 0. All right, I'll keep that in mind, Royce. I'll contact both you and Ken to cover this at a later point, if that's okay for the both of you. So the entry and exit parameters or the location can also be changed at a later point here. So if you go into the toolpath menu, you can choose to edit entry or exit. And then what EnRoute allows you to do is just drag around the entry and exit point to wherever you'd like it to be. Going back once more into the options here, I will first remove the entry and exit. And then going back into here, I'll remove this tool and I will tell it first we're going to be using 10 mil tool. We'll set it to 10 as well. And we do have the possibility to add additional tools to it as well. So you'll see here that the first tool is always going to be defined as a rough tool. And in this case, the second one can be either a clean or a fine tool. So a clean tool will typically offset, as you can see, the width here is 1.9. What that means is it'll offset the rough cut by 1.9. Typically, it's half the diameter of the clean tool. And what this clean tool will do is it'll actually offset the top tool so it can go along. So the largest part of the material will be routed away by the rough tool, and then afterwards the clean tool will come in along the entire edge to create a finer border on your piece. And if you preview it, it will look like this. Then going back into it, I can also quickly show you what the fine tool will do. So basically the fine tool, EnRoute will simply put the fine tool into the corners where the rough tool would not be able to reach it. So that is the difference between the fine and the clean tool. I often use the clean tool when I'm designing a sign with smaller letters, and then I'll use a conic tool as a clean tool. And what that will allow me to do is, let me just go back into here. So if I remove this one, and I will either take a engrave tool, or I can also show you with this conic tool. As a clean tool, I'll go into the parameters, and here I'll also be able to check this as a 3D toolpath. And what this will do is it will allow the tool, maybe this is a bit of a large tool for this, but it'll show you very clearly here in the corners that by checking the 3D toolpath, it will allow the tool to go up into the corner and make a very clean edge, as well as provide a 3D-like effect. So let me see if we can see that in here. So holding down Shift with the right mouse button, I can rotate this and zoom and drag it around with the respectively the scroll tool and the right mouse button. So going in here, you'll be able to see that the tool actually lifts up in the corner. And when we preview this, you'll also be able to see that the edge here will be a lot cleaner, as opposed to only using a rough tool. So I believe now we've covered everything from the routing offset. So we can go forward with the hatch fill and the island fill. So typically a hatch fill would be used to route out large squared pieces, I would say. If you go more into an oval one, or if you have an object which has a lot of pieces in there or letters, then you would, for example, go for the island fill more quickly. So the hatch fill in this case would simply travel back and forth to route out everything. in this one, you'd require a lot more tool lifts if you're doing the hatch fill here. So in this case, I'll just delete this quickly. In this case, I would probably go for an island fill. As for the parameters, most of them will be pretty close to the ones of the routing offset. In this one, you'll still have the optimizations, which will focus mainly on doing the fewest amount of tool lifts and going back and forth the least amount of times. So with this one, the island fill as well as the hatch fill, you'll also always be able to set up an overlap. Depending on whether you're routing 3D or 2D, you'll have to increase this. In most 3D cases, it'll have to be 95 or 85. If it's slightly 3D, like very, for example, a shower tray, if you're routing the foam core for it, I have set it as low as 4% using an end mill without any problems. And that will increase or decrease your routing time considerably. As far as the other parameters here, they're the same as the routing offset. And for the island fill, they're going to be typically the same as well. So in here, you'll have mostly the same parameters as the routing offset as well. One more thing for the hatch fill, you can see that you do have the possibility here to set up a hatch angle if you would like to do that for some reason. So you could change the degree of the tool pathing like this, for example. So going into the engraving strategy, so engraving strategies can be added to both closed shapes as well as open shapes, while the island fill and the hatch fill you'll only be able to add to a closed contour. Going into the engraving here, we'll either do that with an engrave tool, but I like to use conic tools for this as well. So you can just set an engrave depth, for example, here, and it will simply engrave this line to that depth. But you also have the possibility, so let me just preview this. So here it'll just do that V-shaped cut over the contour that we've designed. But for the engraving, we also have the possibility to do a 3D engrave, for example. Let's say we do an internal one. Set that to 15. And then maybe I'll have to increase the depth of my plate. So let's do 15 mil. Put this in the middle. And we'll cut this to 50 as an external one. And as you can see here, it has put 3 tool paths around it. So it'll use both the shape of your tool, so the 45-degree cut, and then the cutting depth of it to add additional contours. And this way it's going to cut down into the material as following. And for this one, you could also check the square corners, and then it'll be more easy to notice the difference that I was talking about earlier. So as you can see now, the corners going down are no longer rounded, but they're squared like the top piece. If you have a curved line, of course, you also have the ability to, or if you have a waving line like we saw last time when I did the rapid texture, you have the possibility to follow the contour. So if you import like a DXF, which has a bunch of contours that vary, for example, in the Z-axis, following the contour will simply, you'll have to set the depth here. Does not matter, it just has to be more than 0, so you can accept it. And then it'll actually just put it where the contour is, because our contour here is at 0, it'll also does not cut into the plate. But in my example where we apply most of these techniques, you'll be able to see what I mean. So lastly, we've come to the drilling. So you have the possibility to set individual drill points, drill a circle, put a drill array. You can drill center objects, corners of a plate. Most of the times, if you're using the ATP, you'll have strategies for drill centers. And then what that'll do is, if you have multiple objects on your plate, you can drill center of objects. And then here, let's go into drilling. Drill 3s. Here we can choose all contours or just drill circles only. In this case, it doesn't really matter. And as you can see, it'll put drill points in every contour right in the center. For the drill array, so a regular drilling point, you can just set up the coordinate for it, or you can do that by graphics. So here we can set a depth by graphic. Here, of course, also we have the possibility to set the feed rates, passes, and so on. In this case, I will just leave that unused. And now it will kind of allow me to set up drill points everywhere I wish until I use my right mouse button. If you're going to drill arrays, you also just select your drill type, choose your columns and rows, do by 10 by 10, and the spacing you can do by width. I typically tend to use by horizontal spacing, and I set it to 32, which is typically the distance in between drills on a drill bank. And then you can set up the start coordinate, or also by graphic and clicking, and then it'll just create an array of drills for you to use. Another possibility would be to use the, just hold it down here, drill along a contour. So you also choose your drill. Here you have a spacing type to hold numbers, hold the spacing, just put it in the corners, inside or outside corners. Typically I would use hold numbers or spacing. And here, let's say you set, I want 15 drill holes at a depth of 4. And then based on your contour, it'll automatically choose the spacing for you. So stepping into a more practical example of what we have here. I'll import what I prepared earlier. So these are the contours that I've been working with. So I just wrote this text. I created an offset to this by offsetting the closed contours. For my text, I copied that to a different layer. So just the text as well as the offsets for it. And to this, I've then applied a 1/8 inch end mill and the engrave as fine and clean tools. And for the clean tool, I've set it up to do a 3D toolpath. And so if you would preview this, maybe I'll make my plate a bit smaller, then I don't have to take a resolution that's very large. And just center it by hitting Control F5. And then if we go into the preview here, up the DPI a little. And as you can see for the letters, it does create this slanted edge with that clean engrave toolpath. And for the texture here, I use the rapid texture tool. Which I've put on layer 3. And by simply adding that texture, it already makes your design look a lot better. I use the rapid texturing tool a lot just because it makes designing a lot easier, as I'm not the best designer of signs. So and here I would have used then the 3/8 inch ball and mill, which is about 9.5 mil, I think. And I have simply set it to follow the contours, as my texture made it so that the contours are waved along the design. So I think I've covered most of the popular routing strategies in EnRoute. If you have any questions, then I'd be glad to answer them. So for Royce, does this happen on every EPS, or is it just some? If you could email me or email our support mailbox some of those, that would be great. You can email the support at support@inksci.eu, and I could check some of those for you, and maybe if need be with the developers as well. For Ross's question, depending on your machine, if it has an automated tool changer, I would output all of this at once. But of course, for this design, I would first also, on layer 1, I would first copy this, and then I'll do I'll add another layer, and then go to layer 4, and then Control-Shift-V this one to put on my routing offset. So I delete this one and this one. I'll just pick an end mill here. Let's see, 10, yeah, and I would just cut to the full depth of it. Still cut out the piece, and then of course what you want to do is make multiple copies if you need on your plate, nest these in whatever way you see fit, or use the automated nesting, and then output them. And typically I would output them based on tool or strategy. For this one, I would have to first select everything. And then here, I would probably do it in this order as it suggests here. So first the engrave. I'll probably do first, yeah, the engrave, then the island fill, and then, of course, cutting it out. For automated toolpathing, I would cover that in another session. I believe it is on the list. I would have to check when exactly. If you have any specific questions, please feel free to email us at the support mailbox, and then we might be able to cover whatever you need to know through a TeamViewer session already. How do you resize those, Terry? Because if you do that with the precision input dialog, you could simply uncheck the proportional when scaling. So the toolpaths are just scaled exactly how your contours are rescaled. Here you can construct one by height and width. Does that answer your question, Royce? You also have the possibility, let's say you here can put on 250 by 250, and then just click wherever you want them. I believe there's also an option for the box reader. Let me just see if it. So here you could enter a enter an Excel sheet, which includes the width and height of your boxes, and it'll generate them all automatically in EnRoute. And you have the possibility to toolpath them as well with whatever strategy you have predefined, and you can choose to use the block nester to nest them at the same time as they're imported as well. That's probably the easiest way. If you have a lot of rectangles you have to cut out, then I would suggest really using the solution here, using the box reader. Yeah, that would, yeah, just in the draw rectangle tool, if you can do that here by just dragging, or if you choose that second option here, you can do that by height and width. Text via Excel sheets, I'm afraid not. You could, however, create a bunch of DXF files and process them through the automated toolpathing and apply an engraving strategy to it that way. But we could look into creating a solution for that from reading that from an Excel sheet. I will have to follow up on that though. For the horizontally mirrored imports, I'll have to check that with the development team. I'll have to come back to you on that later. It could potentially be a setting in your EnRoute preferences. Let me just see. But I can't instantly find something in the preferences file about that. I'll have to follow up on it, and I'll get back to you once I have more information on it. Royce, for that one, I might be able to get in touch with you. Maybe we can do a remote session to cover the issues that you faced with importing. Maybe we can work around them or fix them through changing some settings. All right. So if all questions have been answered, or unless you guys can think of anything else, let's see. And which driver or which post processor are you using, Terry? It could be that if the post changed between two versions, that the auto park has been built in there. All right, just let us know through the support mailbox if the auto parking is causing you any troubles. If it's in the post processor, we can take that out if you'd like to. Okay, so unless there are any other questions, I think we can conclude the session for today. Should you think of anything else, just let us know through the support mailbox, and we'll get right back to you. All right, great. Thank you all for attending, and I wish you all a nice day.